NASA has released one of the strangest images taken by the James Webb Space Telescope. This telescope, launched 3 years ago, is 1.5 million kilometers from Earth. It's orbiting the Sun, searching for distant space objects, and now one of its most familiar new pictures has been taken. Our hunger and thirst for knowledge made us explore the world. Although we cannot visit these places, we have built telescopes that can. Among them, the James Webb Space Telescope, JWST, is the most powerful and dynamic telescope. JWST will act as a time machine, a planetary observatory and a window into the universe's deepest mysteries. But how did that amazing project survive? Let's go back to the early 1990s. After the Hubble Space Telescope changed our understanding of the universe, scientists began to dream of a successor that could look deeper into space, beyond the limits of Hubble's field of vision. This dream gave birth to the JWST project, with one main goal: to observe the first galaxies that formed after the Big Bang. That's right, this telescope was designed to look 13.5 billion years ago. Building the James Webb Space Telescope was no small feat. It took 10 years of planning, designing and overcoming many challenges. The program, officially launched in 1996, is a joint effort between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. These organizations combine their expertise, technology and resources to bring this telescope to life. The construction of JWST is an amazing mission. The telescope has several key components, designed for a specific role in this global journey. To understand the process, let's look at these parts carefully. The most important part of the telescope is the main mirror. The 6.5-meter mirror has 18 hexagonal segments, covered with a thin layer of gold. It is the largest telescope ever launched into space and is designed to capture faint light from distant galaxies, stars and planets. Its size and precision allow JWST to detect objects billions of light-years away. Sunscreen also protects. This 5-layer structure, the size of a tennis court, is designed to protect the eye from heat and sun. Each protective layer is made of a material called capton, coated with aluminum and silicone to reflect the sun's rays. This shield keeps the telescope at a temperature of -233 degrees Celsius, which is necessary to observe weak infrared signals without interference. Next is the Integrated Science Instrument Module, ISIM, which contains 4 main science instruments, including a near-infrared camera, a mid-infrared instrument, and spectrographs. These instruments analyze the light collected by the reflector, allowing scientists to study everything from the birth of stars to the atmospheres of exoplanets. In addition, JWST has a space bus that carries everything. The telescope contains electrical, communication, actuation and computer systems, the telescope's nervous system, that allow it to function as it flies 1 million miles above Earth. Building such a complex machine is not cheap. The total cost of the JWST project increased to $10 billion. This figure covers everything from initial design and engineering to launch and ongoing operations. It is one of the most expensive scientific instruments ever made, but its capabilities are worth every penny. Now that we know what a telescope is made of, how does it work? JWST is a big camera in space, but it doesn't take pictures like a camera. But he captures light from the farthest reaches of the world, thousands of years away. But how does this work? A telescope absorbs light in the infrared spectrum. What is infrared? Because the objects seen by JWST are so distant, such as distant galaxies and stars, their light extends into infrared wavelengths. By combining this light with a large gold-plated mirror, JWST will be able to see things that our eyes can't see. The instruments process the light, turning it into images and data for researchers. When we see the amazing images from JWST, it is important to remember that they are not in color, at least not as we see them. The moon often falls outside the visible spectrum. Different colors correspond to different wavelengths, so scientists assign colors to these wavelengths to create the images we see. This process does not end there. These images need to be improved by combining data from multiple exposures and removing noise before rendering. This excellent practice makes the final images very beautiful and scientifically important. Remember when we said the James Webb Space Telescope would help us see the Big Bang? What does this mean? JWST will see the first galaxies and stars formed hundreds of millions of years after the Big Bang. Because light takes so long to travel, looking at distant galaxies is looking backwards. When JWST takes pictures of these ancient stars, it captures a moon that is more than 13 billion years old, giving us a glimpse of what the universe looked like shortly after it was born. The James Webb Space Telescope made history when it launched on December 25, 2021. After its successful journey aboard ESA's Ariane 5 rocket, it will head to a special place called the Second Lagrange Point, L2. About 1 million miles from Earth. This position provides a stable environment with a clear, unobstructed view of the world. In July 2022, NASA released the first stunning images captured by the JWST, including Webb's first deep field, offering the deepest and sharpest infrared image of the universe ever captured. These early images provided a glimpse of galaxies that formed just a few hundred million years after the Big Bang, giving us a new perspective on nebulae, galaxy clusters, and more. In July 2024, to mark the telescope's second anniversary, NASA released a striking image nicknamed the Penguin and the Egg. These aren't just random shapes. What we are actually seeing are two interacting galaxies known as ARP-142, located 326 million light-years away in the Hydra constellation. The spiral galaxy NGC 2936, distorted by its interaction with the elliptical galaxy NGC 2937, forms the Penguin, while NGC 2937 represents the Egg. Over millions of years, these galaxies have been slowly pulling and twisting each other, sparking bursts of new star formation. In a short period of time, the James Webb Space Telescope, JWST, has made discoveries from Earth that expand our understanding of the universe. One of the most important achievements is the discovery of some of the oldest galaxies ever formed, giving astronomers new insights into the birth and evolution of the universe. These first galaxies, formed a few hundred million years after the Big Bang, are beyond our reach. With the power of imagination and determination, JWST can look back billions of years and reveal a time hidden by mystery. These ancient galaxies are important because they represent the building blocks of the universe as we know it today. By studying them, astronomers hope to learn more about how galaxies form, grow and evolve over time. The light from these galaxies has traveled billions of years before reaching us, which means that JWST will observe it and look back in time. This ability helps scientists piece together the timeline of the universe's evolution, from the mysterious time after the Big Bang to the artificial universe we see today. JWST's unique feature is its ability to detect infrared light. As the universe expands, light from distant objects is stretched and moved into the infrared part of the energy spectrum. Hubble, the JWST's predecessor, was limited in its ability to observe these wavelengths, but Webb's powerful infrared capabilities make it perfectly suited for observing distant galaxies. Not only does it allow astronomers to see farther than ever before, but it also enables them to peer through clouds of cosmic dust that obscure objects in visible light. However, the JWST isn't just revealing new insights about distant galaxies, it's also making incredible observations about exoplanets. Exoplanets, or planets that orbit stars outside our solar system, have been a major focus of modern astronomy. Scientists are particularly interested in finding exoplanets that could potentially harbor life, and the JWST is already contributing to the search in ways that previous telescopes could not. One of JWST's first discoveries was the discovery of clear evidence of water vapor in the atmosphere of the exoplanet WASP-96b. This is obvious, because the presence of water vapor is a strong indicator that the planet may have the conditions for life as we know it. WASP-96b is a Jupiter-like gas giant located 1150 light-years from Earth. Although WASP-96b is not a candidate for life, it's too hot and inhospitable. The discovery of water vapor in its atmosphere demonstrates JWST's ability to analyze the chemical composition of planets. Distant planet. The discovery of water vapor in WASP-96b is a major milestone in outer space science. Astronomers have been interested in learning more about the atmospheres of distant planets for years. The ability to detect and analyze the chemical components of these gases indicates their formation, evolution, and life. JWST's instruments are so sensitive that they can detect subtle changes in the planet's atmosphere as it passes in front of its star. This process, known as microwave emission, allows scientists to follow the path of the star's light through the planet's atmosphere, revealing the presence of molecules such as water, methane, carbohydrates, and oxygen. Water vapor detection begins on WASP-96b. JWST is used to study many other planets, including dwarf, rocky, and Earth-like planets. These terrestrial planets are important because they have the right conditions for liquid water to exist on the surface, which is essential for life. By analyzing the atmospheres of these planets, scientists hope to identify potentially habitable worlds. In addition to searching for water vapor, JWST will help scientists understand the dynamics of the outer atmosphere. For example, it can detect changes in temperature, pressure, and chemical composition of the atmosphere over time. This can provide valuable information about the planet's climate, including its ability to support life. In addition, JWST's ability to detect faint signals from distant exoplanets can reveal biological signatures, molecules that show biological activity, such as oxygen produced in photosynthetic organisms. WASP-96b's discovery of water vapor in the atmosphere has set the stage for future discoveries that will one day change our understanding of the universe. As JWST continues to observe distant exoplanets, our understanding of the diversity and complexity of planetary systems will deepen. Here is the edited version of the article, even closer to answering one of humanity's age-old questions: are we alone in the world? JWST, with its advanced technologies, is poised to make significant contributions to this ongoing effort. JWST has also provided new insights into star formation, black hole activity, and more. By observing these regions and phenomena, astronomers gain unique insights into how the universe works, from the birth of stars to the behavior of supermassive black holes. How does JWST compare to the Hubble Space Telescope? For more than 3 decades, Hubble has provided us with amazing observations, but its main focus has been on visible and ultraviolet wavelengths. Because of its ability to capture infrared light, JWST can peer through clouds of dust in the sky and see the universe in a way that Hubble cannot. The future of the James Webb Space Telescope is bright. Scientists hope to continue to study the past, exoplanets, and conditions that could support life. The discoveries have changed our understanding of the world, and there is no telling what else will be discovered in the years to come.